Algebra lesson 5.4 notes. This is all about a new formula called point slope form. So point slope form is exactly what it sounds like. It's when they give you a point, like a coordinate point, and they give you the slope. So you are going to be writing it. It's a non-vertical line. Slope is still m. Slope is still going to stay m. And the point is your x1, y1. And it's written in this form. Y minus your y1 equals m, which is the slope, times the quantity, which just means parentheses, we're going to add or subtract something in here, x minus the x1. Okay, so I know that sounds crazy and that's big, and I'm going to write it on my board so you don't have to memorize it right now, but here's what I want you to know. This original y is going to stay y in your formulas. This first x is going to stay x. But all three of these other letters, these other variables, y1, m, and x1, are going to be numbers represented by m is going to be the number that represents the slope, and the x1, y1 are the two numbers that represent the ordered pair. Remember, I told you it's going to give you a point, an x1 and a y1, and you're going to substitute those numbers in here and here. So the formula will end up being something like y minus, let's say, 2 equals 1/2 parenthesis x minus 7 or whatever. So let's do a few of these. It explains here's why it works, and you can definitely read all this, but I'm going to just show you, and then if you want to come back up here and look at the here's why it works, this will be better to understand after we do a few. Okay, so down here on A, write an equation in point slope form. That's this big bad boy. And it's going to be a line that passes through the point -3, 6 and has a slope of -5. Okay, so literally there's no math involved. All I want you to do is plug in -5 for the slope and -3, 6 for this x1 and this y1, and that's it. And you're done. So here we go. Y minus my y1. That's 6. This is my x-coordinate, this is my y-coordinate, 6. Equals m, which is the slope, which in this case is -5. Oops, I knocked that over. Times the quantity, x minus my x-coordinate. Okay, here's something tricky. My x-coordinate is -3, so I could write -3 here, but that's going to be x minus negative. There's going to be two negatives in a row. So anytime one of these is negative, since we're subtracting, we're just going to add, because that would be the same thing as minus minus, two negatives in a row, 3. Okay, done. No math. Nothing more to do now. All right, so you try B on your own, or I can try it with you if you're not ready yet. Here we go. X-coordinate, y-coordinate, slope. Y minus my y-coordinate, which is -4, and since we're subtracting, negative is going to make this one a plus 4. Equals my slope, which is 2/3, times the quantity, x minus my x-coordinate, which is 8. Done. That's all there is to it. All right, I'll show you the reason we need this. If we're graphing, sure, we know that the slope is 2/3, but what is my coordinate that I'm going to start putting a dot on? I don't have a y-intercept, so I need a point. So my point is 2, 1, because this is my x-coordinate, my x1, and this is my y1. So it's going to be 2, 1. And my slope is 2/3. So if I know that my first point goes through 2, 1, I'm going to go over to 2 up to 1 and put a dot. And then I'm going to count up 2 over 3, rise over run, 2 over 3, up 2 over 3. And if it goes this direction, it's going to go back down the same direction in the pattern, down 2 over 3, 2 over 3. Put as many dots on there as you can just to keep your lines really nice and straight, and arrows on both ends. All right, B, the point is going to be x1 here, my y1 is here. Notice this is a plus. If this was a plus, then that means it originally was negative because it's minus a negative. So my point is actually going to be 4, -7. And my slope is -4/5. All right, so let's go graph this. Put your first dot at 4, -7. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. That's why this graph is so much bigger. And then down 4 over 5, because that's a negative, you're going to have to go down 4 over 5. That's going to be off the graph. So you can still go the other direction. Just be sure that when you do, you're going up and to the left, because what I want you to notice is it needs to be going downhill from left to right, because this is a negative slope. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Let's try to get one more dot on there. Up 1, 2, 3, 4, 1, 2, 3, 4, 5, barely. All right, draw in your line, straight as you can, arrows on both ends. Okay, let's write an equation in point-slope form. If here's one of my points, and it doesn't matter which one you use, there's always going to be multiple right answers. I always just use the first one I see. So 1, -4, so that is going to be my x1, that is going to be my y1, and my slope I'm going to count from dot to dot. What is my rise over run? So you rise 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. So the slope is 7 over 3. So the slope is 7 over 3. Oops, that's a 3. Okay, so the formula in point slope form again is y minus my y1 coordinate, which is 4, equals slope, which is 7 over 3, times the quantity x minus my x coordinate, which is 1. And again, I could have used -2, -3 and changed, and this would have been slightly different, which is still correct. All right, B. If you want to try B on your own, push pause and try B on your own. I know that it's a negative slope. So my slope, I need to write negative, is going down 1, 2, 3 over 1, 2, 3, 4. It's down 3 over 4. So it's down 3 over 4, -3 over 4. My first dot that I'm looking at is -1, 2, 3, 1, 2, 3, 4, -3, +4 is the first point I saw. So that is my x1, y1 that I'm going to use for this formula. So here we go. Y minus 4 equals -3/4 times the quantity x, that would be minus -3, so it's going to be +3. Okay, and again, you could have used this point, which was 1, 1, which actually may have been easier, but that's okay. All right, now we got some work to do. We don't even have a slope, and I want you to write something in point slope form. That's a problem, because all we have are points. We have no slope. So how do we find a slope if all we have is 2 points? I hope your brain went to this. y2 minus y1 over x2 minus x1 is always how you find your slope from 2 points. So here we go. This is my x1, y1. This is my x2, y2, because it's my first set of coordinates and my second set of coordinates. So y2 minus y1 is -6 minus 4 over -3 minus 2. -6 minus 4 is -10. -3 minus 2 is -5. When you divide 10 divided by 5, -10 divided by -5, and negative divided by negative is +2. So I know now that my slope is 2. If I know my slope is 2, all I have to do is use one of the points to make my x1, y1. It does not matter which point you use. I always just go for my first one just out of habit. So if I know my slope and I know a point, let's write the answer. Y minus my y1, which I'm using 4, equals my slope, which I just found is 2, times the quantity x minus my x coordinate, which is 2. All right, on the back. Oops, sorry, there's your answer, on the back. Use the table below to write an equation in point slope form. Convert it to slope intercept form. So, you guys have a little bit of work cut out for you. First, let's take 2 of these points and just call it my 2 points. Let's say 10, 640, and let's say 3590. 30, and 590. Doesn't matter which points you choose. I just chose those because they were the first two. And the first thing we need to do is calculate my slope. So once again, y2 minus y1 over x2 minus x1. 590 minus 640 over 30 minus 10. 590 minus 640 is negative 50. 30 minus 10 is 20. Negative 50 divided by 20 is negative 2.5. So now I know my slope. If I know a slope and one of my points, doesn't matter which point you want to use, I can write an equation in point slope form. Y minus 640 equals my slope, negative 2.5, times the quantity x minus 10. All right, here's where it's new this time. I need to solve it. And the reason I'm solving it is because I'm converting it to slope-intercept form. In case you forgot, slope-intercept form is y equals mx plus b. So I need y by itself, just like it is up here. So I need to move things around to get y by itself. So I'm going to start by distributing. Negative 2.5 times x is negative 2.5x. Negative times negative is positive 25, I believe, if I did that right. On the other side, y is almost by itself. It's subtracting 640, so I need to add 640. Y equals negative 2.5x. 25 plus 640 is 665. Okay, and then the last thing it says is, what do the slope and y-intercept represent? This slope represents meters per second that my balloon is going down. Balloon is descending, because that's why it's negative. And then the 665 is the initial height. That's where the balloon started from, and then it started descending from there. Okay, for the you try, I really do want you to try this time. I'm actually going to take a picture of my answers instead of working them out on the video, and I will upload that. But try it on your own and then compare with my answers. If you're not sure how to do each one of these because I'm not actually working it out with you, go back and find where there's an example of each one of these types of problems on today's worksheet earlier. So check for my answer key that I will upload a photo of, but try these you try on your own.